Hello everyone. Today we discuss about volumetric analysis, that is titration. It is a analytical, or you can say quantitative process which is used here for determination of volume measurement of solution. Volume measurement of unknown solution in a reaction. In grade 12 volumetric analysis, we do redox titration where KMnO4 potassium permanganate is used as an oxidizing agent. Such titrations where potassium permanganate is used as a titrant are known as permagnometry. Permagnometry titration on the name of permanganate. So in our syllabus, we have two titrations, redox titrations. One is the reaction of KMnO4 with Mohr salt solution. Other one is the reaction of KMnO4 with oxalic acid solution. In first titration, KMnO4, in both titration you can say KMnO4 act as an oxidizing agent, whether that one is of a titration of KMnO4 with Mohr or a KMnO4 with an oxalic acid. And Mohr salt behaves like a reducing agent. Same with the oxalic acid, it acts as an reducing agent in the reaction mixture. Standard solution. Standard solution are solution of precisely non-concentration, and these are broadly classified as primary standard solution and secondary standard solution. Secondary standard solution. Primary standard solutions have high purity and less reactivity. For example, Mohr salt solution and oxalic acid. So these are the primary standard. Whereas secondary standard solutions have lesser purity and more reactivity. An example here we take potassium permanganate. So in our redox titration, potassium permanganate, that one behaves like a secondary standard solution, whereas Mohr salt or oxalic acid, the two are primary standard solution. Apparatus used for the titrations are burette, in which we fill potassium permanganate, flask, in which we have a mixture of dilute sulfuric acid with Mohr or oxalic, test tube, pipette, burette. Burette is filled with potassium permanganate, which behaves like a titrant and acts as an oxidizing agent in this redox titration. During the titration, permanganate ion of potassium permanganate, which is purple, the resulting solution is purple in color. In acidic medium, it changes to divalent manganese ion, which is colorless. So the color of the potassium permanganate changes to purple to colorless. As potassium permanganate is a colored solution, so we take a upper meniscus reading. In case of colorless, we note down lower meniscus reading, while in case of colored, we take upper meniscus reading. Anti-parallax card is used to eliminate error in reading. Burette should be rinsed properly before use, because to remove any waste sticking to their sides, otherwise volume of the solution changes, and this will change the molarity, as the molarity and volume are inversely proportional to each other. Rubber pinched cork should not be used. We take KMnO4 solution in a burette and in a flask, as in case of titration of KMnO4 with Mohr salt. So in a flask we take 20 ml of Mohr salt solution. You can also take 10 ml Mohr salt solution, which is pipette out, and one test tube full of dilute sulfuric acid of concentration 4N. In case of titration of KMnO4 with oxalic acid, flask we take 20 ml of oxalic acid, or you can also take 10 ml of oxalic acid. 20 or 10 ml of oxalic acid is pipette out, and to this we add one test tube full of dilute sulfuric acid, 4N dilute sulfuric acid, and along with this we heat the reaction mixture to a bearable temperature. Don't boil the solution. To accelerate the reaction, we simply heat here. Pipette is used to measure volume of the solution taken in a flask for the Mohr salt and for the oxalic acid part. Never be held from its bulb, because glass is there. Because of the body heat, it gets expand, and because of the expansion, volume changes. Should be rinsed properly. Last drop must not be blown out, because drops left in the jet is the extra of the volume measured by the pipette. Mohr salt. It is a double salt. It is ferrous ammonium sulfate. Its formula is FeSO4, NH4 whole twice SO4, ferrous sulfate, ammonium sulfate, and 24 molecules of water of crystallization. It acts as a reducing agent. So the ferrous part during the titration changes from Fe2 plus to Fe3. Increase in oxidation number is there. Molecular mass of Mohr salt is 392 gram per mole. Now we wish to prepare 250 ml of M by 20 Mohr salt solution. Molarity is number of moles upon volume, and if this one is in ml, so we convert this into 1000. Converted this into the liter by using a conversion factor. 1 liter equal to 1000 ml. N is the number of mole, which is given mass upon molecular mass. So the formula of molarity is given mass upon molecular mass into 1000 upon V. Here given mass we have to calculate. Molarity is 1 by 20 here. Given mass we have to calculate. Molecular mass is 392, and the volume we have to prepare is 250 ml. By solving this, W, that one is 4.9 gram. It means if you dissolve this 4.9 gram of Mohr salt in 250 ml of water, then the molarity of the resulting solution will be M by 20. During the preparation of solution, when you are dissolving Mohr salt in a distilled water, then we add dilute sulfuric acid to prevent the hydrolysis of Mohr salt. Otherwise, ferrous sulfate, it get hydrolyzed to ferrous hydroxide. Oxalic acid, its formula is COH whole twice dot 2H2, 2 water molecules of crystallization. It acts as a reducing agent. in a redox titration of KMnO4 with oxalic. So the oxalate changes to carbon dioxide here. In this case, we heat the reaction mixture to speed up the reaction. Rise in temperature, speed up the reaction because temperature, that one is directly proportional to the kinetic energy. Molecular mass of oxalic acid is 1 to 6 gram per mole. Now the task is to prepare 250 ml of M by 50 oxalic acid solution. What we do here? We use the formula of molarity, given mass upon molecular mass into 1000 upon V. Molarity is 1 upon 50. Given mass, we have to calculate. Molecular mass is 1 to 6 and volume we prepare, that one is 250 ml. After calculating, we get W equal to 0.63 gram. It means if you dissolve this 0.63 gram in water, into 50 ml water, then the molarity of the resulting solution will be M by 50. Endpoint of the titration is colorless to permanent pink, which arises because when all the reducing agent, whether we are having a Mohr or a oxalic, has been oxidized, the excess of KMnO4 is not decomposed and impart permanent pink color. Sometimes during the titration, brownish color is observed in a flask that arises because of incomplete oxidation of KMnO4. Also, you can say because of the formation of hydrated MnO2. In the titration of KMnO4 with oxalic or KMnO4 with Mohr, we use 4N sulfuric acid. N means normality. So, let's discuss about molarity and normality here. Normality is the given mass upon the equivalent weight into 1000 by V. Equivalent weight is the molecular mass upon N factor. So, normality, that one becomes equal to given mass upon molecular mass into N factor into 1000 upon V. Whereas molarity is given mass upon molecular mass into 1000 upon V. So, finally, normality is N factor into molarity. So we have a sulfuric acid here. Sulfuric acid, it has two ionizable hydrogens. If you just check the structure of sulfuric acid, it has two OH group. So it has two ionizable hydrogens here, ionic hydrogen, H plus. So N factor for sulfuric acid is 2. So in this case, N normality becomes equal to 2 times of molarity. So we have to prepare 500 ml of 4N sulfuric acid. Normality of concentrated sulfuric acid is 36.8 N. So we use a normality equation, N1V1 equal to N2V2 concentrated dilute. N1 here is 36.8. V1 you have to calculate. N2 you wish to prepare 4N and of volume 500 ml. So V1 here comes out 4 into 500 upon 36.8, which is 54.34 ml. Then the resulting solution normality will be 4N. So by this way you can prepare 4N sulfuric acid, which we use in redox titration of KMnO4 with Mohr or KMnO4 with oxalic acid.